Hello everybody, my name is Michael Hirsch. As Benjamin already mentioned, I'm working for Bosch Software Innovations. I'm located in Stuttgart. And I'm one of the committer of the hawkBit project. So I'm here to show you some slides about hawkBit and software updates in the IT. We already heard Julian about on the device, what's happening on a device when a software update crashes or breaks. So hawkBit is on the opposite, it's in the back end and manage your software updates. And so I have a few slides and I want to show you hawkBit in action a little bit. So I have brought a little demo with me with an LED stripe, so we'll come to that later. So let's get started. So hawkBit, before we coming back to the hawkBit project itself, is like the question why we need software update in the IoT, right? And this is where I always start and asking around, so who is running an IoT system developing an IoT system? Okay, I thought there would come a little bit more hands up on an IoT day, but that's good. So, and who has an IoT system? Who is capable of software update in this IoT? I think there are the same hands. That's actually good. So if you're having an IoT system and connecting devices, you should be able to have software updates in place. So first of all, everybody probably has it because of security, for sure. You read on every new article, newspaper, another DDoS attack, another hacking on IoT devices. And why? Because people are getting lazy of updating them. So there are mostly security patches out there, but they are running on old firmware and old Linux systems and everything. So this shouldn't be a problem when you have software updates. You can run them, update them. It's kind of work, but you should do that because this is important and this is make IoT secure, right? Another point is what many people maybe don't consider in the first place when thinking about software update is the way of being agile. And being agile, it's a point when you are able to run software updates easily in your system, then you can push new features out there to the customer, make the customer happy. And I just read today in the news that Tesla was updating the new models, so they extended the range of the battery life so people get out of Florida. So that's awesome. So they are able to continuously updating the system just in time, right? So you can bring devices out of the field and testing them by software updates and bring new software and features out there and test them in the field. It's not on your desk. So when it's working on your desk, it's fine, but it's on the field, like Julian already said, in the smart lock. So it's on the field, you're doing the software update, and then it crashes. So this is not the way we want to have it. So putting software update in the first place when starting an IoT solution should be one of the first things to think about. So why hawkBit? So thinking about software update, it's from the backend side perspective, it's always the same. What you want to do is like you want to tell the device, please download the software and install and flash it. What's happening on the device, it's domain specific. Every device behaves differently, has different limitation on resources, maybe has 2 partitions which can switch, maybe do it on the fly, depends on the device. But from the management perspective is when and which URL is getting distributed to your devices is mostly the same. So you're telling your device, now it's time to update yourself with this software. And this is what hawkBit actually is all about. It's in the back end and management, your software update rollout. Another thing is, as we already talked about, is the backbone of the IoT. So it's the way to flash in your device and to bring new features and software updates, but it also has to be secure. So if this is the way to update and bring in new software on your device, this is also their first point of hackers to be able to run software on your device, right? So this should be in a secure manner, and it's all the same. It doesn't matter which one device is. If this is the tunnel to your device, which tells you now software update and it's the truth of trust, you should be able to secure it. So this is the backbone. And you can fix everything with the software update as long as your client software update is running. And software update at scale, it's not that easy. Thinking about updating 10 devices on your desk is not a problem. You go there and flash them manually. But what happens if you have 1 million devices out there distributed in the world? So you want to group them, you have to test devices somewhere which are testing your new software and rolling out in groups. So manage these kind of millions of devices It's not trial, and this is actually, doesn't matter if you're updating a Raspberry Pi or a smart home system, it's all the same way. They want to download some software and update them and telling you everything is okay. This is the overall picture of hawkBit, and I just want to show you the picture to tell you how you can integrate with hawkBit in the server way. So to the northbound, we have the user interfaces. We have a graphical user interface, you will see later. This is just easy to getting started and to manage all the devices and the rollout of this. Everything you see in the management user interface, you can also do via API. So you can build on top your own management interface. You can do it from a system telling hawkBit now distribute software. So everything you see on a UI, you can do also via a RESTful API. To the southbound, we have an easy HTTP way. We call it Direct Device Integration API, which this is a pull mechanism. So devices ask, is there new software from me out there? Is there new software? So they can ask every 5 minutes, they can ask one in a day, they can ask once in a week, in a month, whatever. So they're asking for software, and hawkBit just tell them, yeah, there is new software, here you get it to download. And what we see in the IoT is not every device is speaking HTTP, right? So there are so many protocols out there, so hawkBit also is aware of it. And we have a device management federation API because hawkBit itself, it's not a device management. It only takes care of software updates and when the software update should be rolled out to your devices. So mostly IoT solutions have the fully featured device management in front where the devices connect first. So you can integrate your device management with your protocols within hawkBit. It's AMQP based and it's just a messaging technology with push notifications. So this is what hawkBit is capable of. Another thing is, hawkBit is not delivering only like a file, because mostly, if you have a gateway, this is not only running one application, it's running a Linux stack, it's running an OS stack, it has application software, maybe there's a runtime on it, Java runtime, whatever. And so hawkBit has a metadata model which allows you to package it virtually in hawkBit and to manage it. So you have different files which you can put together in a software module and label it with a version, label it with a key, so the device knows what to do with these files, and then put them all together to one release. So putting them to one release, this will make it easier to roll out one release, which is actually multiple files, right? This is a common software update in mostly all IoT scenarios if you have a complex device. If you have a single sensor with one firmware update, it's also fine, but you can also you are able to model complex devices in software in hawkBit. What the device gets, it's kind of a descriptor which has all the checksum of all files, which is calculated by hawkBit or given to hawkBit, and all the download URLs where the software can download it from. And it's all pluggable, and you can generate your own download URLs. You can download it from Amazon S3. You can download it from hawkBit itself. It's having an artifact content delivery mechanism in there. And so you can configure it of your needs on the device. So we also do it in Bosch. We also ship UDP co-op download URLs, so the Lightweight M2M device is able to download it from co-op download server. I said I don't have a lot of slides because I want to show hawkBit in action, and we are here in an IoT day, so I thought we should have some IoT devices here. So the IoT device is a Raspberry Pi, as everybody knows. And it's not easy to show software update. It's kind of boring. So if you do software update and you say, okay, now on the Raspberry Pi is running another version, hooray. Nobody can see it, right? And people just believe, okay, he did something. So my idea was to show you like having an LED stripe, and all LED is a device which can be flashed by switching colors and light. Benjamin had kind of a demonstration, 2013 I think it was, in Germany, in the JAX, where he used an LED stripe on Twitter, so this is an homage on Benjamin, showing like LED stripe again after 4 years. So I'm happy to show you the demo. Hope everything is working fine. It's always the same thing and running demos on one conference. And if you have questions afterwards, I'm happy to answer them all. So I'm already running. This is a Docker-based setup of what I was running. There's running a Docker hawkBit, a MySQL database where hawkBit is configured to. And this is what you get when you start like with hawkBit plain. This is just the open source project. There's no code in it, which is not open source. This is just the open source project. So what you get, the resolution is not the best, maybe for the graphical user interface. It's a little smashed together, but I think you can read everything. What I have is, I have the gateway, which for each LED, these are 144 LEDs, and each LED will show up and pop up in hawkBit. This is just a plug-and-play mechanism. If I delete them, I just will demonstrate it. They are polling every 10 seconds. The gateway is polling them, and they will come up again. Like they will just show up again. Maybe they're missing now. Okay, there we are. Okay, now we are back at 144. So why they're polling it every 10 seconds? Because the server can tell the client when he should re-poll again. So this is using the HTTP poll mechanism of hawkBit. So the easiest thing is you don't have 1 million devices out there yet, probably, so you have a small portion. And hawkBit is also able to tell you, like, I want to just update a couple of them or all of them with software, right? So I assign him just the color red. I will explain in more detail what's happening under the hood later. And, okay, I don't see them. And what they're doing is like, they're polling, getting this descriptor of all the downloaded files they can download them and execute them. What I told hawkBit, what is behind a software module, for example, the red one, which I saw, this is just a red JSON which tells him their RGB color, what it should show. So back to the deployment view. So what we see is now we have an LED 1. This is somewhere here up. They're just counted up. I can see what the device told hawkBit back. So he is able to send feedback and tell him, yeah, the update was successful or the update failed because of a reason. And this is up to the client, which is running on your device, which tells you, I'm doing this, I'm doing that. There's just free text field you can put in there. So some of them are generated by hawkBit itself because it knows that somebody is downloading something. He tells also a download is successful. This is all what hawkBit is aware about, but the device can also put any feedback they want back to hawkBit, and hawkBit is just storing them as reference. So you know what time, when the device installed the software you told him to install. So this is not the way you want to probably handle 1 million devices out there, right? Or 10, even if you have 1,000, you don't want to update them all at once. So hawkBit is able to select your group of devices you want to update with the software of a specific version based on many filters. So you are able to tag devices. I can create tags, tag them manually or via API, and just tag them by drag and dropping on a tag. So if I want to filter them, I can just go to the task tag and I see all the filter devices. So I can tag them like all in Germany, all in London, all in Europe, whatsoever. This is a manual step, or I can script it. A more advanced way is more like target filters. This is a dynamic language to find out which devices should get which software. So I can write any kind of language here with a little bit content support. I can tell them all the name. These are all LEDs which I have. These are 144. And I can even go to metadata. If the device sent metadata of a device, which hardware revision number, or which software currently running, which is not in sync with hawkBit maybe, or which other kind of serial numbers. Oh, I'm running out of time. It's impossible. I just have a few slides. Okay, I have to speed up a little bit. So you are able to filter all your devices what you want. So you can make, this is the big advantage, what we're thinking of every IT solution software update needs is to have some kind of a rollout. So you don't want that all devices download the same software at the same time, right? Because this will make your internet connectivity break. So what you're able is you can create a rollout. So I don't know which color you can see well. So let's call it blue. So we take the blue software update and tell him on which devices I want to do it. So let's just, for a simple way, just use all devices. But within the devices, I can say, oh, I want to have a subgroup, so I want to update the first 10 LEDs first. So these are my test group, for example. So you have developers out there, maybe having devices at home. This is what we are doing at Bosch Smart Home. We have a continuous delivery pipeline, which developers get always the latest software. And after that, I tell him, okay, update the rest of them. I don't care. So what I can put thresholds in there. So if the first test group is failing with a 50% failure rate, the rollout should stop. I don't want to roll out the whole world because, I don't know, your software might be not working well. So this would maybe help on the smart lock system. So let's just run this thing because I'm a little bit running out of time. So if you're running this thing, you can see that the groups are generated, and I have a group of 10 LEDs. This is my first group, and they're starting updating, hopefully. And I told him if 50% of this group is finished, so when the scheduler kicks in, he should update all of the rest of them. So I hope I have 10 LEDs that are up there, so it's not yeah, you can see them. And as I said, the LEDs are polling every 10 seconds, so it takes a loop of them to retrieve the new update, and you will hopefully see them all going to be updated soon. And while this is running, you can click in and see what the group 1 did. So they are all updated in the group 1. These are the targets in the group 1. So this is LED 0 to 9. And you can see that now the rollout is going up to all the LED stripe. So I have another minute, I think, right? So, okay. There's another thing, like if new devices popping up, how to handle if new devices popping up. If a new device pops up, I want to automatically give them the latest software, for example. So this we can also do as well. So if all LEDs popping up, I tell them, give them all the color green, for example. Now I have a problem. Oh, wow. So if they're polling next time, they automatically get the color green. So if I delete them and new LEDs come popping in, like I have a large LED stripe, they will automatically switch to green. Because this is like you're having devices out there in the shop, and you don't know when they get sold to the customer, and you don't know when they get connected, right? So, but the first thing a device normally is doing is bringing to the latest software. So this is possible with hawkBit as well. So we have this auto assignable mechanism based on filters. I think my time is up. Is it? Okay, isn't it? Questions. Okay. If somebody want to know more about hawkBit, I'm here all 3 days long. So I'm happy to show you more, to answer questions, how we do it. Or I'm also interested how you guys doing software updates currently in your IT solutions. So thank you very much.
We do have time for a couple of questions, though, so if there are any questions for Michael.
What do you require on the device side? Is that a lightweight M2M client? Or?
Oh, this one?
Yeah.
This is actually own implementation. It's on my GitHub account if somebody want to look at it. It's just like half an hour typing, quick and dirty, I have to say. This is just running Java runtime with HTTP Paul and asynchronous. But we're also using a lightweight M2M and co-op. And with hawkBit, this is not totally open sourced. There are some parts, the connector which does the device management to hawkBit is not open sourced yet.
Other questions?
Just a quick question. hawkBit server, is it multi-tenant or mono-tenant? Can I deploy a hawkBit server and run multiple different companies with is rated? Or do I need to deploy one hawkBit server per, let's say, application or company using it?
Actually, hawkBit itself, it's multi-tenancy capable, and it's also running on HR. You can start 10 hawkBit servers, and they communicate with each other using Spring Cloud Bus. So all the push notification to the UI doesn't matter on which server you're connected and which notification happens on which server. So it's totally cluster capable. So it's based on Spring Boot. So if somebody are working with Spring Boot, it's kind of easy to get in touch with hawkBit and all the configuration possibilities.
You said security was really important, so how do you ensure that the clients that are connecting to you are the clients you expect?
May I get the question right? How we?
So we said at the very beginning of this that security is paramount in the IoT. So when your clients connect to hawkBit, how do you know that they are your clients and not somebody else's clients?
Oh, okay. hawkBit has many, and this is also pluggable, so if you have an own security mechanism in your cloud where you deploy hawkBit or on your server, this you can implement in your way. In this scenario, and hawkBit has only like limitation like gateway tokens, they have some token mechanism. We have some, if you have a load balancer in front, you can use headers which the TLS terminate in the load balancer and tells you like the certificate-based headers. This is also what we're doing in hawkBit. If there are some specialties, you need to implement it by your own, like how your devices get connected to your solution. But what we see mostly is like devices connect mostly to a device management system because you want to have all the functionalities of device management. And so it's just a question how the device management talk to hawkBit. And this is mostly not a direct device connectivity. But the HTTP based is tokens and certificates possible.
And maybe the next speaker can get set up in the meantime.
Can this be used for operating system updates as well, or is it just limited to applications?
So behind the speaker, I
Sorry, is it limited to application updates only, or can it actually be used to update the operating system of the device? I mean, are there any implementations today for any devices that where it actually...
hawkBit itself doesn't care what kind of file you upload to them, so it can be a zip file, it can be a RPM file, it can be a Java runtime file, it doesn't matter.
Yeah.
hawkBit just ship it. What is running on the device, hawkBit itself has no touch on it. So you have to, because on the device it's so domain specific how to flash a device, you need to know what you downloaded and how to handle it.
Right, but what my question is, are there any implementations out there today using hawkBit to actually flash a device?
Yeah, there are, as we are using it at Bosch. Okay. So we're using for some of our devices, we're using hawkBit as a software update mechanism. And there is a hawkBit C implementation out there for SW update, it's called, and it's for Yocto Linux, which is out of the box hawkBit compatible. And it's on GitHub, it's open source, it's in C. Sorry.
Thank you very much. Okay, one last question while we switch laptops.
Yeah, one last question. So we spend a lot of time this year on firmware updates over LP1. Is it still listening? Or? Yeah.
Oh, sorry.
Yeah.
I thought, sorry, you're going.
Yeah, one last question. So we spend a lot of time on firmware updates over LP1s, where you have very limited bandwidth. Do you account for differences from firmware to firmware, binary differences?
hawkBit is not calculating any binary difference. We've been asking a lot if hawkBit should do a binary diff, but it's also very, very complicated in some scenarios how to find a binary diff. We are talking to I'm from Bosch, from automotive guys, and this is so complicated to get which software is running on which car for which year it's built and all the stuff. And build a binary on the fly for this car, it's so complicated. So this is what maybe in the community can be built, but we are not focusing on it currently, to building binary diffs.
Thanks again, Mikael.